First, we will discuss about Module 15, lesson titled Molecular Mass, Mole Concept, and Percent Composition.
So, what is mole? Mole is the unit of measurement in the International System of Units for amount of substance.
Molar mass is the mass in grams of 1 mole of a substance. The unit of molar mass are grams per mole, abbreviated as G and mole. The mass of a single isotopy of any given element, the isotopic atomic mass, is a value relating the mass of that isotopy to the mass of isotopy carbon-12.
What is molecular mass? Molecular mass is the sum of the atomic masses of all of the elements in that molecule. This is applied to compounds, while in ionic compounds, where there is no individual molecules, formula mass is generally replaced. However, we still use the term molar mass. What is the purpose of molecular weight? The purpose of the molecular weight is used for determining the approximate size and concentration in any elements, may it be compounds or ionic compounds. What is formula in getting the molecular mass? To get the molecular mass, multiply the subscription, the number of atomics, times the atomic mass. Refer to the periodic table of elements, and add the masses of all of the elements in the molecule. For example, in getting the molecular mass of the sand, which is compound of silicon and oxygen, silicon with atomic mass to equal to 28.086 is added to oxygen with atomic mass of 16, multiplied by the subscription 2. So, silicon have 28.086 plus oxygen have 16 times 2, which is equals to 28.086 plus 32. Oh, how did we get the 32? So, the 32 is the product of 16 times 2. So, 32 plus 28.086 is equals to 60.086 grams per mil, which is the molecular weight or molecular mass of sand or silicon dioxide.
Percentage composition of a compound gives the relative amount of each element present. The formula of percent composition is the percent by mass equal to mass of element divided by the mass compound multiplied by 100%. So, the sum of percentages of each element in a compound should be 100. For example, a certain newly synthesized compound is known to contain the elements zinc and oxygen. When 20 grams sample of compound is decomposed, 16.7 grams of zinc remains. So this is the solution. Mass of compound is equal to 20 grams, then mass of zinc is equal to 16.7 grams. And the mass of oxygen is equal to 20 minus 16.7 equals 3.93 grams. And the percent of zinc is equal to 16.7 grams zinc divided by 20 grams multiplied by 100%. And the result of this is 80.35% zinc. The percent of oxygen is equal to 3.93 grams oxygen divided by 20 grams multiplied by 100%, equal of 19.65% of oxygen. The calculations Makes sense because the sum of the two percentages adds up to the 100%. By mass, the compound is mostly the zinc.
Let's go on to the Module 16. The lesson title is about chemical reactions and equations.
Writing chemical equation. Writing chemical equation is an equation as a symbolic representation of a chemical reaction, wherein the reactant entities are on the left side and the product entities are on the right side, with a plus sign between the entities are both reactants. So I have here the example. So in the first reactant, in the first given of the reactant and the product, these are called coefficient. Coefficient is in the front of the formula give the relative number of the molecules of the formula units involved in the reaction. So in the first this is called the reactant. The reactant is a starting substance in a chemical reaction. And the product is a substance result of the reaction. This arrow between the two of them, between the reactant and the product, this is called the reactive form or yields. It is also useful to put or indicate the state of phase of substance in the equation.
The law of conservation of mass requires that the number of type of atoms be the same on both sides of reaction arrow. Students are expected to deduce the reaction coefficients if they are not given. This is called balancing the reaction. There are lots of tricks of balancing equations, but they all rely on trial and error. You must fill in coefficient and count atoms to see if the atoms counts on the both sides of the equation match. Warning! When you balance chemical reaction equation, you can adapt a systematic method that helps reduce the time involved in the trial and error process. Or you can leap right in. When we refer to a balanced equation, we will assume that this is the case unless otherwise specified. The method we have outlined called balancing by inspection of essentially a trial and error method. It can be made easier, however, by observing the following rule. Balance first the atom for elements that occur in only one substance on each side of the equation. The example of balancing chemical equations. As we can see here, we have carbon, hydrogen, and oxygen. The number of carbon here is 6, the number of hydrogen is 12, the number of oxygen here is 6 plus 2 equals 8. On product side, we have carbon, hydrogen, oxygen. The number of carbon here is 1 times 6 equals 6. The number of hydrogen is 2 times 6 equals 12. The number of oxygen here is 2 plus 1, we have 3. As you can see here, carbon and hydrogens are the same, except the oxygen. Oxygen, 6 times 2 plus 6 is 18. As you can see here, we have oxygen, 6, we have 6 here, times 2, 12, equals 18. We have balanced the substance on each side of the equation.
Types of chemical reaction. A combination or synthesis A plus B equals AB. A combination reaction, sometimes called additional reaction, is one of which two reactants forms a single product. Some more complicated combination reactions have more reactants and or products, but the general 10 is more the numbers of different chemical substance to decrease as the action progresses.
This is the example of combination reaction.
Decompositions or analysis AB or A plus B. A decomposition reaction is one in which a single reactant breaks apart into a more than one apart. Decomposition reactions are the reverse of combination reactions. An examples of decomposition reactions is the composition of hydrogens peroxides.
Single displacement. During a single replacement reaction, a reactant element take the place of the chemical similar element that is part of a compound. An element and a compound react to form a different element and compound.
Note the zinc metal takes the place of the copper ion in the compound. Zinc is more similar to copper than to nitrogen or oxygen.
Double displacement. During the double replacement reaction, two compound exchange element to form two different compound. One type of double replacement reaction is metathesis. In a metathesis reaction, a pair of unique compound exchanges ion in an aqueous solution.
Example of double replacement reaction. And that brings us to the end. I'd like to thank you for your time and attention.